And we're recording. Hello, geometry. How we doing? We have our lesson 10.3 of probability. It is our last lesson of probability. And if you're watching this right now on Sunday or Monday, I just wanted to give you the heads up that later on in the week that we will be doing MAPS testing for the third time this year. Just giving you that heads up. But let's focus on the lesson here. We're working with what are called two-way tables, okay? So two-way tables have like two situations that are occurring, like two choices. You can do this, or you could do both, right? You can do just one action, you can do just the other, you could do both, or you could do neither, okay? So take a look at this example here about students at school. There are some students at school who play a sport, and there are some students at school who do not play a sport. That's a pretty safe assumption, right? You either do or do not. And then there are some students that have a foreign language class, and there are some students who do not take a foreign language class. So this two-way table helps you figure out how many of each student there are. There are 14 students who do both. There are 23 students who don't play a sport but take a foreign language, and so on and so forth. And so this table allows you to see each of the groups so you know how many there are of each. And when you total this column together, there are 24 students who play a sport. Some of those students who play a sport take a foreign language and some do not. But when you total them together, we know how many there are. Same thing for taking a foreign language. We could total them together and we can know how many there are, some of which who play a sport, some of which do not. So that's what a two-way table does. So let's fill in the rest of this two-way table. How many people have been to Mexico? 9. How many people have not been to Mexico? 16, because you add the 5 and 11 and the 6 and 3. Now adding down, how many have been to Canada? 11. And how many people have not been to Canada? 14. So when you total these numbers together, these two total to 25, and so do these two, okay? These two numbers are both going to total to the same amount, and that's 25, because there are 25 people in this survey, okay? So how many people were surveyed? I just said that, 25. How many people went to Mexico? Well, we would take a look at this right here. This number is the number that have been to Mexico. How many people went to Mexico? Went to Mexico but not Canada. So you would look at the went to Mexico row and then not Canada. Your answer, 3. How many people have been both to Canada and Mexico? Have been to Canada, have been to Mexico. Where do they cross? The 6. So there are 6 people who have been to both. How many people have not been to Canada? Well, the not Canada column can be found right here, 14. And how many people have not gone to either Canada or Mexico? Well, the not Canada and not Mexico lines up right there with 11. That yellow was a bad choice, I'm sorry. 11. So I hope you got a feel there just from seeing me quickly fill that in, how this two-way table works. And then we can start to do some probability problems with these. Like, what's the probability of choosing someone who's been to Canada? Well, how many people have been to Canada? 11 out of 25. So the probability of choosing someone who's been to Canada would be 11/25, right? Something like that. So let's continue on and make a two-way table completely from scratch. As each person entered the theater, Aaron counted how many of the 105 people had popcorn and how many had a drink. He found that out of 84 people that had popcorn, only 10 did not have a drink. 6 people walked in without a popcorn or a drink. So the question you want to ask yourself here when you make these rows and columns is, what are we describing here? We are describing people who eat popcorn and who drink these sodas. So you either have popcorn or you don't have popcorn. You either have a drink or you don't have a drink. With these two-way tables, you have to break it up into something very distinct like that, okay? And now where these crisscross, hey, people who have both, people who only have a drink, people who only have popcorn, people who have neither. So when we read these, we know that there were 105 people that entered. So boom, we know that that's the total. He found that 84 people that had popcorn, only that out of 84 people that had popcorn, so, oh wait, 84 people had popcorn, that of the 84 people that had popcorn, only 10 did not have a drink. No drink, but had popcorn, so therefore 74 remained that had a drink, because there were 84 total people who had popcorn. 6 people walked in without a popcorn or a drink. Okay, so there's that. And then that's all the info that we've been given. So let's think about what do we know? That there were 105 people surveyed and 84 had popcorn. So now we can determine how many people didn't have popcorn. 105 minus 84 is 21. And now that we know that 21 people didn't have popcorn and 6 didn't have a drink, well then those other people had to have had a drink who didn't have popcorn. 21 minus 6 is 15. And well, now that we have those numbers, it's even easier here. 10 and 6 gives us 16 people who didn't have a drink. 74 and 15 gives us 89 people that didn't have, or that do have a drink. And you can see here that both of these add up to 105, which is what we want. There are 105 total people in this survey or in this observation study. I paused to get a drink real quick. Okay. So what is the probability of finding someone who had popcorn? Well, how many people had popcorn out of the total? The questions that we ask ourselves are going to be the same as the cards. How many kings are there out of the total number of cards? Well, now we're not looking for cards, we're looking for people who are doing a specific task. This task being they're eating popcorn. So 84 out of 105. Okay? Now, some of these are going to be able to reduce. Okay, so you got to be on the lookout for things that can reduce. 84, let me pause real quick. Okay, so if you remember, if you Google Desmos Scientific Calculator and you punch in your fraction, it will give you a simplified fraction. Boom, the answer, 4, that's very zoomed in, 4/5. So 84 over 105 simplifies to 4/5. I would encourage you to use that because, you know, look how much time that just saved me. I didn't want to think about that, neither do you. What's the probability of finding someone who has a drink? Well, there are 89 people who got a drink out of 105. I'm going to just do it on the back end here real quick. 89 divided by 105 reduces down to, that's it. They have no divisors. Okay? Drink and popcorn. So this is like, when it comes to the word and, this is where they are intersecting, right? Here is a drink and here is a popcorn. There are 74 people that had a drink and popcorn. That one doesn't simplify either. Drink or popcorn. So how does drink or popcorn work? So how many people had a drink and or had popcorn? So so these people didn't have popcorn. Let me do a prettier color. How about this bright green here? Oh, I already used that green. Let's do this blue. These people didn't have popcorn, but they had a drink. So they would be in this group. These people had both, so they would also be in this group. And these people didn't have the drink, but they had the popcorn. So all three of those groups satisfy what the question is asking for, drink or popcorn. These are the only people that didn't have a drink or popcorn because they literally have no drink, no popcorn. So add those two together, you get 99 out of 105. And that simplifies down to 33/33. 35ths. Okay. You know, we keep we're making it spicier here. Drink given popcorn. So if I tell you that they had popcorn, that means we're only talking about these 84 people. That's important to take notice of, right? Given that they had popcorn. So it's like the playing cards. If I give you a diamond, you know that there's no other cards in there. There's only 13 diamonds. Well, if I give you the people who had popcorn, well then you know that there's only 84 people because I said that, right? That's in the two-way table. So of those 84 people, how many had popcorn? 74 out of 84, which reduces down to 37 over 52. Now, this is a symbol. This symbol means and. So how many people didn't have a drink and they didn't have popcorn? The answer being 6 out of 80, or sorry, not out of 84. We're back to a total, right, of 105, which reduces down to 2 over 35. And lastly, given that they don't have popcorn, who doesn't have a drink? So given that they don't have popcorn, 21 people, 6 out of those 21 people don't have a drink. That simplifies down to 2/7. I encourage you, if at all you're like, okay, where did that number come from? Just listen back to my words, rewind it a little bit, and I have faith that you'll know what thing is coming from, right? So this lesson gets a little long, and you know what? I might save one for class. We'll see where we're at. Let me pause real quick. Okay, so in the previous, I just quickly drew this box here so you didn't have to watch me do that. In the previous question, we had to come up with the whole popcorn, no popcorn, drink, no drink. So I'd like you to read this question, and I'll read it out loud right now too, but listen to it, and I'm going to have some questions pop up on screen as to what do you think the names of the categories, so to speak, should be, okay? And you'll choose the best options. So a survey of 1,108 employees at a software company finds that 621 employees take a bus to work and 445 employees take a train to work. Some employees take both a bus and a train, and 312 employees take only a train. So what should the names of the categories be? So you just saw some options, and when you read the question, you should hear bus and train. So you either take the bus or you don't take the bus. You either take the train or you don't take the train. It's possible that you take both, right? Those people would be in the bus and train section. But you either take the bus or you don't, right? I don't care if you take the train. You either take the bus or you don't. You can take both. I'm not offended by that, right? But when I ask you, do you take the bus to work? The answer is either yes or no, right? There's no in between. So train, no train, bus, no train, or bus, no bus. So a survey of 1,108 employees. Boom, there's the total. Finds that 621 employees take a bus to work. Okay, take a bus, 621. And 445 employees take a train to work. Take train to work, 445. Those 445 people, some of them might take a bus. Some of them might not take the bus. But the thing is that there's a total of 445. There's a total of 621. Some employees take both a bus and a train, and 312 employees take only a train. Only a train means no bus. So 312 take a train, but no bus. And now we can start to do some addition and or subtraction. So 445 minus the 312 gives us the remaining. Give us the remaining amount here, 133. Some employees take both a bus and a train, and 312 employees take only a train. Okay, I'm just making sure that I read that correctly. What is, and that we need to keep going. So 621 minus 133. What is that? 621 minus 133 is 488. And then we know how many people took the bus. How many didn't take the bus? Well, we know there's 1,108 total, so 1,108 minus 621 is 487 to find the remaining amount there. Well, of the 487 people who didn't take the bus, 312 took the train, so subtract the 312 to figure out how many didn't take the train. That'd be 175. And then total up these no train people to figure out how many people didn't take the train. 488 plus 175 is 663. And I like to just make sure I did all the math right by adding these two numbers together and adding these two numbers together and confirming that they add to the same amount. So 663 plus 445 is 1,108, and 621 plus 487 equals 1,108. And I'd like to show you that, I'd like to point out one other thing. If you add these four numbers together, those are the four unique groups. People can only fall into those four groups. So if you total all four of those together, you will also get 1,108, because check it out. You have 1,333 who do both, plus the 312 people that are only the train, plus the 488 people that are only the bus, plus the 175 that don't do anything. 1,108. There it is. It all checks out. So what is the probability that a randomly chosen employee takes a bus or train to work? How about some answers pop up on screen for you? Bus or train. So these people, or means I don't necessarily need both. These people take the train. These people take the bus and train. That's okay. They're doing both. I mean, or does not exclude the people who do both. It doesn't say, who are the people that only took the bus or only took the train, right? That would exclude. But if you're just saying bus or train, the people who do both fall into the or category, and then these people only took the bus. So those three groups of people took a bus or train to work. And when you add them all together, which hopefully you did, you had those answer choices. 133 plus 312 plus 488 is 933 out of 1,108 employees. Which, if I go to Desmos to help me out here, 933 divided by 1108, does that simplify? It does not. They have no divisors. What is the probability that a randomly chosen employee takes a bus given they do not take the train? How about you try that one on for size as well? Given they do not take the train, what is the probability that they took the bus? So try that one on for size. So given that they do not take the train, is the 663 people. So when it says given they do not take the train, what that's saying is, okay, we're only talking about those 663 people. And of those 663 people, what is the probability that a randomly chosen employee takes the bus? Well, of those people, 488 took the bus. So 488 divided by, you should see my screen right now, I was going crazy, divided by 663. Take a look at that in a fraction. Oh, take a look at that as a reduce. Oh, okay, that doesn't reduce either. We're done. And we're just under 20 minutes. Maybe I'll make up some more two-way tables in class. I don't think we need to have this video too long. And with that, I appreciate your time. I appreciate you answering those 3 questions. We're on the downhill for the rest of the year. Yeah. Have a good rest of your day whenever you're watching this, and I'll see you.